All right, so the homework we assigned was this. Write the electron dot formulas for a nitrogen atom. Then write the electron dot formulas for hydrogen atoms. Show the sharing arrangement for a molecule in which these hydrogen atoms share electrons with the nitrogen atom. Well, let's start with that, okay? So, nitrogen, electron dot formula has 5 electron dots. Anybody that doesn't understand how we got that? You don't understand? Okay, I just want to make sure. All right, then hydrogen has 1 electron dot, and I need 3 of them. Okay, and then the next thing was to show how they share those electrons. So nitrogen needs, or would like to have, 8 electrons. Right now it has 5, 8 valence electrons, because it actually has a total of 7 already, but it only, I'm sorry, yeah, 1, 2, 3, 4, 5, and then the 2 in the lower level. So it has 5 valence electrons, and it wants to have 8 valence electrons in the upper level, or to get rid of all of them. In this case, it's going to be sharing. Hydrogen only wants 2 electrons. 2 electrons is all that you can get in the first primary level, and hydrogen is in the first primary level, so it's only going to have 2 electrons. So we can share these 2 electrons here, and that takes care of hydrogen's wanting to have 2 electrons, but we get nitrogen up to 6 now by sharing these 2. This hydrogen now has 2, which is what it wants, and nitrogen now has 7. And by sharing these 2, now nitrogen has the 8 it wants, and this hydrogen has the 2 it wants. So we've got 1, 2, 3, 4, 5, 6, 7, 8 electrons around the nitrogen. That's where it would like to be as stable as it can be. Okay? And now we want to go to the Lewis dot formula. So the Lewis dot formula, we simply take and write the original nitrogen symbol here. But then where we're sharing an electron, we're going to squeeze these electrons between the element symbols. So we're squeezing those 2 electrons between the symbol for hydrogen and nitrogen. And we're going to squeeze the others. So down here at the bottom, we're going to squeeze these 2 electrons in between a nitrogen and a hydrogen. And over here on this side, this hydrogen or this electron here gets squeezed between the symbol for hydrogen and nitrogen, and it looks like this. That makes sense to everybody? Okay, I don't see anybody saying no. All right, so, all right. Now we want to, from this, then predict what a balloon model for this molecule would look like. Well, let's see. These electrons that are squeezed between these 2 symbols represent a bond, the kind of sigma bond we've been doing, or did in 2 of our models yesterday. So if I have a nitrogen here in the center, I've got to have long balloons to represent that bond, and I have to have a round balloon to represent this lone pair, which is just like we did with water yesterday and just like we did with hydrogen chloride before that. So if I need 3 bonds, the best way to arrange that is I have a bond coming out here like that. Now hydrogen is going to be out here in the end, and I've got to have a bond that's swinging out kind of toward you. All right, and there's a hydrogen coming out here. I got to have a bond that kind of swings back here. Oh, tiny hydrogen back there. Now you don't have to have it drawn in perspective like me, okay? You just got to have 3 long balloons around the thing, and then you got to have a lone pair balloon, which is the round balloon up here somewhere else, okay? That's 4 things around the central atom. You could have put the round balloon down here and the other legs going some other way. But if you did it really the right way, if you turn it eventually, you'll get to pretty much the same drawing I have. Okay? Any questions about how that works? Okay? All right. So let's talk about a grading system for this then. You need all of these electron dot formulas. That's what it said to do. And so I want to give a point to this electron dot formula, and a point for this electron dot formula, and 1 for this one, and 1 for this one. Okay? Then I'm going to give, you got circles or showing how, not circles per se, but I mean we've circled or drawn, connected these electrons to show the sharing, and I've got 3 of those. So this one's going to be worth a point, and this one's going to be worth a point, and this one's going to be worth a point. Then you got your Lewis dot formula, where you squeeze the electrons in between. You still have the lone pair up here. So let's give 1 point for having all the element symbols in our Lewis dot formula, and a point for having the lone pair electrons up here, a point for having the squeezed electrons here, a point for having the squeezed electrons here, and the point for having the squeezed electrons here. Okay? So let's see, that's 7 here, 8, 9, 10, 11, 12 so far. Okay? So in the balloon model, it really doesn't matter to me whether you put an actual circle here like I did, or if you just put a big fat dot or something to show where that nucleus is, or you put an H there. You could have done that, any of those things. But you have to have hydrogens represented in these places, okay, somehow or other, all right? And so each of those hydrogens are going to be worth a point. And each of the long balloon shapes are going to be worth a point. Okay, the round balloon is worth a point. Okay, and the nitrogen in the center could be represented by the symbol nitrogen or a dot. At this point in time, I don't care which one to use. Okay, something in the center that says there's a nucleus there, either the symbol itself or just a dot if you wanted to. Okay, does that make sense? So that's 12, 13, 14, 15, 16, 17, 18, 19, 20 total. Would it be 21? Did I miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Just want to make sure. You could have been right, you know. So that's the total for this, okay? Any questions?